Pubky Arcade started with the hack week and just trying to find different ways to basically use the protocol. James and I basically came up with two different games, and there were some similarities between these two games, and that prompted the product team to kind of merge them into the same project called Pubky Arcade, which is just a showcase of these two different games for now. And they are kind of P2P. There's no central server here controlling anything. So you're using your own home server, and your friend or whoever you're playing with also using their own home server. And the idea here was that some of the projects or some of the things that at first glance might not seem really doable without a central authority, or might become totally viable if you try to find the correct techniques and if you actually care enough to put the effort. Even something like a game, which I think it kind of having referees and sort of somebody that judges and is an authoritative figure, I think is very hardly scripted into our definition of games. But I thought that basically we thought that this could showcase that, well, maybe that's not necessarily the case. And the idea behind both games are, how can we use this basically decentralized system to make games actually playable in a way that's fair and that's trustable, like many of other things that are decentralized and trustable. And so we're using a lot of the same techniques, like a chain of hashes or signing with like your digital signature to make sure something is authentic. And we're using those same concepts here in games. And both of these games are turn-based. And here's our index page. We have a little bit about the Pubky. Okay, so the basic way you connect to your buddy to play the game is one of you, like this is very common, becomes the host, or well, technically the host. Here we don't have a host. Actually, you're both working on your own home servers, but one of you starts the game and the other, again, not literally, but joins. And the whole idea is that the person that's starting the game basically defines some of the conventions. Like it creates an ID for that game and tells the user where he's going to put all of his moves and where he expects the other player to put all the moves. So that's the only thing. There's nothing more special about it. And yeah, this is your public key. Let's go here. So basically, this is now my key, and this is this player's key. And one of them, let's start the game. One of them will be the host. The other is going to basically get this match URI and give it to your friend, and your friend is going to join. So when you create a game, you become the X, and when you join, you become the O's. And this is the typical tic-tac-toe game that everybody's familiar with. And what's happening here is that when it's my turn, and when I click on any of the squares on this board, I'm going to write or basically create a record at this URL slash, for example, 1, which will be the move 1 of this game. And I'm just going to put the coordinate of my move. And I'm going to say, for example, 0, 0. I put my move at 0, 0. And to make sure that you are not going to, at some other time, change your move, we require you to also sign your move. And when you sign it, and this other player who's going to pull this URL and get your move, gets your signature, make sure that you can never claim that you did not make this move. So that's basically how you also prevent it from becoming unfair and open it to cheating, while also keeping it totally decentralized. So now is this player's turn, and let's say it clicks here. And as you can see, there's a little bit of delay because right now our home servers are in their very first versions, and they don't have, basically they don't support sockets. So that's why we had to opt in for polling, and each of these tabs is polling the other home server every 1 second, expecting for their move. And if I move here, I should hopefully win. Yeah. So yeah, very basically, what's happening is you place your moves, you sign it, to make sure that they cannot move back, and you keep pulling each other until the win condition is matched. And this means that we basically can implement any kind of turn-based game using the same system. And hopefully in the future, when we have support for sockets, we can add maybe even more real-time games to this using the same techniques.
We had some additional functionality within this game to keep a score of every player that you've encountered or every player that you've observed a game of. And the idea is that there's no central host for scorekeeping. So every game that's won, anyone who has been either a participant in the game or has just been a passive observer of a game, which is a feature that we would like to add here, they would be keeping their own scoreboard. And then you could build up this network of trusted individuals who could keep score of each pub key, and that way you could have a good idea of the global leaders of the tic-tac-toe game without necessarily needing to watch every single game and without having to trust a central authority there. Maybe not that interesting for tic-tac-toe, but you could imagine something like a poker tournament or some other high-stakes game where you don't have to trust a central host for the game, for the validation of the game rules, nor for the score itself.
So the Battleships game is, while still like a turn-based game, a bit different in two sense. First is that each player has a initial kind of board and an initial state, unlike the tic-tac-toe game, which is just one board global for both players without any initial state. And so that is solved by just adding one more step to all of our moves. And at the beginning, basically, when I'm creating this game, so I need to give it the friend, basically, Pubky first. Then I can define the size of the game. I can add like more ships, configure the game, whatever. Let's just randomize for now. So this is state, and this is also something that we want to make sure that this player is not able to go back and change. So this is our actually first step. While you create your board, you're going to hash it, and then you're going to sign it. And that will be basically the sign for this other player that you've set up everything and the game has started, and now it's their turn to join the game. So let's start the game for this player. Then we have a little copy URL here that we're going to send to our friend. Yeah, so this player now has to set up their board. Again, let's randomize and join. So another thing that's different about Battleships compared to tic-tac-toe is that you, again, because there's no global board, you need your enemy to report your move. Basically, when you move, you make a move on the enemy board, and you are not supposed to know about the state of the enemy board, but you also want to make sure that the enemy cannot cheat. So again, we use the same hashing and signature tactic, and that means that we have every step of the way. We know how the enemy board was supposed to look like, and at the end, when you want to certify things, just as we were talking about it, if there was going to be a central authority that wanted to keep track of your wins in this game, you basically had to show up give up your nonce at the beginning of the game that you chose. And if you want your game to count, and if you basically want the end game to be verified, you have to reveal your random value at the end of the game. And using that, the enemy should be able to basically build every step of the way, hash, sign, and make sure that basically hash and compare with your signature to make sure that you are not cheating if the enemy is the loser. So for tic-tac-toe, you made a move and you had to sign your move, and their other player made a move and they had to sign it, and this was already a hash chain. But here you make a move, and now the enemy has to report your move, and now it's the enemy's turn. So it kind of was like two consecutive turns for one person. So it was kind of breaking the hash chain, but just added a confirmation step. to make sure that the hash chain is not broken and it keeps going from one player to the other. So now it's this player's turn, and here's the enemy board. And well, I'm seeing the enemy board right now. Let's make a miss, for example. So when I click it, it becomes gray. The enemy reports. Basically, I put my move in my home server. The enemy is polling my home server, figure out that I made a move, checks it with their board, and reports back that it was a miss. And here we add the confirmation. So this player one that started the move confirms that I received your report, and now you can go ahead with your move to basically keep the hashing going. And now it's my turn. Again, I'm seeing the board. Hopefully this is it. Yeah, and think it's going to take a bit long, so I'm not going to continue it.
And it's just about recognizing the properties of using the Pubky protocol. Like, you're hosting the data yourself entirely within your home server. So any application that could benefit from that, in opposed to a trusted hosted solution, you also mentioned that we have WebSockets as an upcoming possibility to make it more real time. So potentially going forwards, the performance won't be such a limitation, but it's really just it's possible to build any type of application in this way. It's just a different way of thinking about how you're going to store the data and make it available.